All right, geometry lesson 1.4, angle measure. Before we start talking about angles, the first thing that we're going to discuss are rays. And rays are essentially the building blocks of angles. So the definition I'd like you to write down is that rays are part of a line with one endpoint that extends forever in one direction. And then to model this, let's go ahead and draw. Start with what looks almost like a segment, but on one end, put an arrow, and on the other end, put a single point. And then I'm going to label this point as A, and then I'm going to put another point over here and call that B. And then again, this is a ray because it has one endpoint, point A, and then extends forever in one direction towards point B. Rays are named by stating the endpoint first, then any other point on the ray. So endpoint first, then any other point on the ray. So using the one that we just drew as an example, we've already identified that point A is our endpoint, and it's going towards point B. So state the endpoint first, so we would write the capital A, and then it goes towards B, so we'll put that there. And then because it's a ray, up above it, we'll put a ray with one arrow, and that arrow should always be pointing towards the right. It doesn't really matter which direction your ray is pointing, because I could also draw this one, call that point A, call that point B, and I'd still name this ray AB, because it has an endpoint at A, and it's going towards B. So the arrow here always points towards the right. So differentiate that from a line that has two arrows. Ray just has the one because it only goes forever in one direction. If you choose a point on any line, that point determines two opposite rays. And to illustrate this, we are going to draw a line, arrows on both ends, and then anywhere of your choosing, place a point on that line. And then as you can see, as soon as we did that, we immediately created two rays. I've got the one that goes in this direction in yellow, and then I've got this one going this direction in green. So how I'd like you to recognize that, if in a prompt or any kind of question you see something stating that there are two opposite rays, know that opposite rays just make a line. And then something else that's probably worth noting at this point, because it may come up later, is that lines, when you measure them, like if I grab a protractor and I go to measure that line, all the way across there, I'm going to see that 180. So I'd like you to write that lines equal 180 degrees. And we'll use that a bit later. An angle is formed by two non-collinear rays that have a common endpoint. And just a bit of a reminder there, that term non-collinear means they are not on the same line. So let's illustrate. I put two rays together. They have this common endpoint. And I'm going to label this as point A. Let's make this point B and this point C. So two rays, common endpoint. Some things that I'd like you to identify. The rays are called the sides of the angle. So all rays will have two sides. This one, I've got AC. And then I've also got AB. So naming those. Endpoint first, so ray AB is one side. And then ray AC would be the other side. So when you're asked to name those on the assignment, make sure that you put the arrow up above it and endpoint first. And then something else we'll identify is the common endpoint is called the vertex. So the vertex for this one would be A. The common endpoint is called the vertex. When naming angles, either use the number given or 3 points with the vertex in the middle. And I'm going to go back here. I'm going to copy the one that we already drew so you don't have to draw it again. So you can just use the picture that you had from the last slide. And I'm going to add to this a number 3 here in the interior. So when naming angles, either use the number given. So our number is 3, which is the one I chose. So the angle symbol looks like this, kind of like an acute angle. So angle 4 is one name, or 3 points with the vertex in the middle. And we've already identified that our vertex was point A, so I could call this one angle B, A, C, or it would be appropriate to go the other way and call it C, A, B. So lots of different names that could work. Vertex has to be in the middle, and then your other 2 letters, one comes from one side, one comes from the other side. If there are more letters, like let's say I put D here, well, that gives me more options. I could call this same angle, angle D. I have to have A in the center no matter what, and then B. So example 1, I'd like you to try to draw this, and then we're going to name some things. Name all angles that have B as a vertex, name the sides of angle 5, and write another name for angle 6. So you might need to pause it at this point to give yourself some time to write this down, but I'm going to go ahead and get started. So for A, name all angles that have B as a vertex. And when I'm looking around, I'm seeing that there are 1, 2, 3, 4 angles kind of going around here. And there could be different names, but I'm seeing this first one, I've got a number there, so I'm going to go ahead and just call that angle 6. So that was this one. And then I'm seeing this one. There's no number, so I have to use the points. So B's the vertex, so I know it goes in the middle. So I could call this D, F, B, F. So angle D, B, F. And then the next one, again, I don't have a number, so I have to use the letters. One option, maybe start with A, and then B, and then F. And again, more than that could work, but that's what I chose. And then last one would be in this region. So I could start at E, go to B, and then to A. So angle E, B, A. Part B, name the sides of angle 5. And angle 5 is right here. And I'll go ahead and highlight over that to maybe draw your attention to it. This, in green, is angle 5. And angle 5, just like any angle, will have 2 sides. And they're the rays. So ray AE would be one of them. So capital A, capital E with the arrow. Second one, we could call it AC, we could call it AB, we could call it AD. Any of those are fine. I'll go with my first one, AC. And then part C, write another name for angle 6. So kind of looking at angle 6, let's go highlight in pink. So that's this one. So I could use the points. Oh, don't know what happened there. I could use E, B, D. That could be an alternate name, angle E, B, D. And kind of notice how when I'm highlighting this stuff or going over it, when you have those 3 letters, it's just kind of the pathway that you follow. Like for this one, I'm starting at E, B's in the middle, so I'm going towards that, and then D's the last point, I go that way. And that maps out where that angle is. When you measure angles, you're going to use this tool called a protractor, and there is a tub of these on my desk, so if you need to borrow one, now would be a good time to pass those out. I'm assuming you've had a little bit of experience using these, but I'm going to kind of remind you how that goes. Most protractors are either going to have an actual hole there, or you're just going to see this kind of T where those cross. Whenever you use a protractor, this middle part here gets lined up on your vertex point. But that's not all. In addition to that, every protractor is going to have a horizontal line going across from 180 to 180. You need to line that up with one of the sides. It doesn't matter which one, so I'm going to kind of tilt this way. And then you're able to read the protractor from there and get an idea about where your angle is. So I'm looking at this one. And I'm seeing it's in between a couple numbers. It's in between 50 and 40 or 130 and 140. So I have to choose which one makes more sense. And if the angle looks like it's less than 90, you're going to want to pick the one that's the lower number. So I'm going to count, looks like 41, 2, 3. So that is a 43-degree angle. So why don't you draw an angle on your paper and just practice using the protractor to measure it. If you need to pause it, that's fine. When we classify angles, we have three options. The angle that we just saw would be called acute. We can also have angles that are obtuse. And then finally, we can have angles that are right. And I think, again, these are probably terms you've had before, but let's review them in case we need to. To be an acute angle, the measure is less than 90 degrees. To be obtuse, it is greater than 90 degrees. And to be right, it's exactly equal to 90 degrees. So on the assignment, you're going to be asked to measure some things and classify them. Make sure that your answers match up. Like if your answer is less than 90, you better be saying it's acute. If it's greater than 90, obtuse. And if it's exactly 90, that's the only case where it's considered a right angle. Congruent angles. Congruent was a term we had last time. And just a reminder, congruent symbol is an equal sign with a tilde or just like a squiggle over the top. I'd like you to draw two intersecting lines. All lines, we need our arrows at the end. And when you did that, even though you weren't trying to, you created four angles. And something that we'll focus on in the next lesson is whenever you create those angles, it is guaranteed that this top angle will be the exact same or congruent to this bottom angle. And I put those two arcs on there to signify that. So when you see those symbols in a picture, that is meaning that this angle matches with this one, and then the left and the right also match up, so we put two arcs on that, two arcs on that one. And an arc is just a curve, basically. So if you see that, those mean that they are the same. Angle bisector. Bisector is a term that we've probably talked about a little bit. Bi means two, sect means to cut. So it very much translates into to cut into half. So this is a ray that divides an angle into two congruent angles, or you could say it cuts it in half. So it cuts in half. And halves should always be equivalent to one another. So in this example here, I get to draw and label it. I've already marked that these two angles are the same. So my question is, let me put some letters here. Let's say that's A, D, that's C, and that's B. So I want to know the measure of angle A, B, D. I want to know what that is. And right now I just have some variables there, but I'm noticing that these are marked as congruent, so I know they're equal to each other. So I'm going to set up 7x minus 4 equals 3x plus 28. Because they're each half, they have to be congruent, so they're equal to one another. So then we're going to do some algebra. I'm noticing that I have variables on both sides, a 7x and a 3x. So I'm probably going to subtract the smaller one over to avoid creating a negative, but it really doesn't matter. Did the same on both sides, canceled that out. 7x minus 3x becomes 4x. Copy the rest down. Add 4. So 4x equals 32. And then finally divide by 4. So x equals exactly 8. But that wasn't quite what I was going for. I want ABD, so ABD is this angle. So kind of like we did for segments, I take what I got for x and I plug it back in. So it's going to be 7 times 8 minus 4. So 56 minus 4, which would give me 52. And like all angles, our unit should be in degrees. So the measure of angle ABD is 52 degrees. All right, example 2, I would recommend you probably pause the video at this point and write down what's up here and draw that. And then when we're ready, go ahead and hit play again. I'm going to get started now. Ray BA and BC are opposite rays. So that tells me that together this whole thing is a line, which tells me that when I put all of these 3 angles together, I'm going to get 180. I'm also told that ray BE bisects angle ABF. So if I find that, BE is right here, and I know it's cutting this bigger angle in half. So I'm going to go ahead and mark that this angle is congruent to this angle. Because it bisects it, I know those are the same. And then ABF, which goes from here all the way to here, ABF is 8x minus 6. And ABE is 2 times the quantity x plus 11. So my first thought would be, well, I already marked that these are congruent, so this one's also got to be 2 times x plus 11. And then what stands out to me is I've got 2 parts, and I've also got the whole. So an idea that we used before was part plus part equals whole. So I'm going to apply that right now, and my 2 parts are 2 times x plus 11 plus 2 times x plus 11 equals our whole, which was 8x minus 6. Distributive property first, so 2x plus 22, and we know this is going to give us the same thing, 2x plus 22 equals our 8x minus 6. Combine our like terms, 2x plus another 2x becomes 4x, 22 plus 22 becomes 44, and that equals 8x minus 6 still. Variables on both sides, so let's move the 4x over. Same time, why don't we go ahead and add the 6 over as well. So cancel that out, Got 50 equals 4x. We could divide by 4. Cancel, and if you take 50 divided by 4, we'll find out that x is 12.5. And then looking at the problem again, I want the measure of angle EBF, which I have not found yet, but it's pretty easy to get at this point. We already said that this was EBF, so I just get to plug in. I'm going to do 2 times 12.5 plus 11, which would be 2 times 23.5. which gives me 47, and again, degrees. So feel free to go back to, rewatch, and rewrite anything that you may have missed. And then now is just time to work on the assignment.